we're going to start talking about vectors and scalars, and you learn about that in either Regents Physics or AP 1. We're going to have to go into a little bit more detail. But just the basic definition, our vectors are quantities with magnitude and direction. Important, and scalars are quantities with only magnitude. So direction is not going to be important. Some examples of vectors are displacement, velocity, acceleration, force, momentum, and so on. And some examples of scalars would be distance, speed, time, work, energy, and power. Now, scalars are normal numbers. You can simply add, multiply them. Okay? It gets a lot more complicated with vectors. And if you remember, for adding vectors, sometimes we can scale models. Here's the tip to scale. And another method was by finding components. We're going to practice that and make sure that we're familiar with it. Now, something that you didn't learn about was multiplying vectors. And there's actually two ways to multiply vectors that we're going to learn. One gives you what's called a scalar product, and the other gives you a vector product. I'm not going to go into any more detail. Not going to go into any more detail now, but we will later on in the unit. So here's our first example. We're going to add vectors using our scale model. The person walks 30 meters north and 40 meters, 30 degrees south of east. So I'm going to use a scale of 10 to 1. I'm not going to use 5. So we'll use 5 meters is 1 centimeter. So for this 30, if every centimeter is 5 meters, if I make it 6 centimeters long, that'll be right. So I'm going to start down here someplace, and I'm going to just grab my ruler. I'm going to spin this around. I'm going to take and I'm going to draw a line that's 6 centimeters long. Starting from there. So 6 centimeters is going to take me to Alright, and then I have to do 40 meters, 30 degrees south of east. So I'm going to put a reference line going east. And 30 degrees south of that. So, we're right here. Measure 30 degrees south of that. So 30 degrees takes me to right here. And I'm going to take my ruler. And that's going to have to be 8 long. So I'm going to put this here. And measure out 8. Drawing that there. Now these are already tip to tail. Okay, so now I can just draw my resultant, and I would draw my resultant from the origin to where I ended up. So I'm going to result is going to be right here. It's our result. Now to find out how big it is, I just have to measure it. So here, it looks to be about 7.3 centimeters long. Remember, this is the scale. It's a scale of 5 to 1. So I have to multiply that by 5 meters per centimeter, and that's going to give me a value of 36.5 meters. Now, since the vector, I also have to tell angle. So I'll go back to my origin here. I'm going to draw in a little dotted line going east. That's going to be my reference. I'm going to take my protractor, use it, measure that angle. Measure it right on here, measure along there. It looks like it is at about 20 degrees. North. Okay, we also found components of vectors. So again, this is a review. I want to find the x and y components for the vector. So the first thing you do is draw in the x and y components of the vector. The components themselves are vectors, so they have to be arrows. So A is going up to the right, so AX is going to go to the right, the AY is going to go up. Then we're going to use trig to find them. AX is the adjacent side, AY is the opposite side. I have the hypotenuse. So for AX, looking for the adjacent side, I have the hypotenuse. Adjacent hypotenuse is cosine. So it's going to be 40 cosine 60. So that's going to give me a value of 20. And then AY is going to be 40 sine 60. That's going to give me a value of 34.6. Okay. Now, if it's going straight down or straight left and right, they're easy because none of B here is in the x direction. It's all in the y direction. I'm going to make it negative 80 because it's going down. So you always got to go back and check and make sure you have the signs right. For C, I'm going up and left. So this has to be going left. This has to be going up. CX, CY. So, again, x is the adjacent side, y is the opposite side, so I'm going to use cosine for CX. So CX is 20 cosine 30. CX is 17.3. And whoa, I have to stop myself and check the sign. It's going to the left, so I'm going to make it negative. And then CY is 20 sine 30. And CY is 10. And it's going to be positive because CY is going up. Now, we can use the components to find the result. Okay? And again, this should be sort of a review. Previous example, we had 30 meters north. And then 40 meters, 30 degrees south. So 40, 30 degrees south of east. And if we remember, our result for that was about 36.5 to 20 degrees. So we should find that the result is about 36.5 meters at 20 degrees north of east. When we do it with components, we should get the same value. I'm going to label this one A, label this one B, keep track of our components. Now, A is going straight up, so AX is equal to 0, AY is equal to positive 30. Now I'm going to draw in BX and BY. Here's BX, there's BY. BX equals, again, X is the adjacent side, so I'm going to use cosine for it. So 40 cosine 30, which is equal to 34.6. And then BY is going to equal 40 sine 30, which is 20. And, well, I have to make sure I remember to make it negative, because it's going down. Now that I found all the components, to get the x component of the resultant, I add the x's. So my ax was 0, my bx was 34.6. So that's going to give me rx is 34.6. Ry is ay plus by. So that's going to equal 30 plus minus 20. That's going to give me ry equals 10. Now that I know the x and y components of the resultant, I can construct the resultant. My rx is 34.6, so that means if I make an origin and I start there, I have to go to the right 34.6. And then my ry is 10, so I have to go 10 in the y direction. Now here's my resultant. I have to find that, and I have to find the angle. Now to find the size of the resultant, I can do the Pythagorean theorem. So r squared is 34.6 squared plus 10 squared. And if I plug that in my calculator, I'll get a value of r of 36.0 meters. And then for my angle, I have the opposite side and the adjacent side, so I want to use tangent. So tangent of theta is going to be 10 divided by 34.6. And if I plug that in my calculator and do inverse tan, I end up with 16 degrees. So those sort of match what I had up here. Okay, my angle was a little bit off. I measured a little bit wrong. But we got pretty much the same answer. So hopefully that looks familiar to you, and you'll be able to replicate that without too much trouble.